If I remember right, very recently, I'm about dead certain of this, Formlabs bought them, shut them down, because they were like, oh, that's gonna be tough competition. So they gave them a big payday, if I remember correctly.
You said you're a big fan of SolidWorks.
I am.
How long did it take to develop some sort of proficiency to use it?
I don't know, I've been doing this for about 25 years. Seriously, SolidWorks has some embedded tutorials right in the tool itself. Whenever I get a new engineer that has never touched SolidWorks, that's the first thing I have to do. I say, I want you to go through every single last tutorial in SolidWorks, and I want you to show me your work. Typically, after a week, they're fairly proficient. Now, SolidWorks, like any very capable CAD tool, is kind of like Photoshop. It's like any other really powerful tool. Any one user in industry is probably only going to use about 10–15% of its overall capabilities. Very powerful tools. But for just day-to-day modeling stuff, you want to make a new knob for your drawer or whatever, you could get the hang of that in a week or so. It's not really hard. You're going to take longer to get efficient at it and to really understand the button and switchology of the software. You know, the first while you're going to be like, oh, where was that button again? But again, SolidWorks UI, user interface, is the best. They have search windows just about everywhere, and they're fuzzy searches. So if you don't quite remember how to do a thing, you can type it into your best guess. It's almost always right. It'll say, "Is this what you want to do?" You go, "Yep, that was it," and you click on it.
I think the big thing is you have to really be able to think in 3D too.
You do.
And that's the problem that a lot of people have. I've worked with a lot of engineers, older, more mature engineers seem to have more trouble with it.
Yep.
Younger folks, no.
Yep, you're right on that. And I've seen it both ways. You know, a lot of the senior engineers, I'm becoming one, and when I say senior, I mean in age, not necessarily capability. A lot of the senior engineers I've worked with in the past 10–15 years, especially mechanical engineers in the DoD industry, they've been using CAD since the 80s. You know, they were brought up on it. Now they're still using draft tables, but they were also using AutoCAD.
Yeah, I know that AutoCAD has a free version on their
Yes.
website. Does SolidWorks also have it?
No, SolidWorks has what they call a maker version, and they do charge a yearly subscription, and I think it's $40 a year. It may be $60. I have a huge bias to SolidWorks, so I don't mind paying it because when I'm at home, you know, I can do stuff in SolidWorks in my sleep, so it's just very convenient for me. I would say probably the next two most capable ones is probably Fusion 360 and Tinkercad, and they have free versions.
If you're a member of Experimental Aircraft,
Not anymore.
they have a reduced price SolidWorks. I think it's like
Not anymore.
They quit doing it?
Yep. I wore that out because I'm a pilot. I've been in that. I've been in the EAA for a couple of decades, and they stopped doing it about 10 years ago, unfortunately. But SolidWorks reduced the price. It used to be $100 a year. All right. Yeah, you can see on this slide there's, you know, some inductor forms. This looks like a commercial product, but made a little nifty bracket carrier for it. Something else I like to do, like I have one of those little nano VNA network analyzers you can buy for about $100. You know, those things are awesome, as long as you calibrate them between every use. But they're kind of delicate, right? What do you expect for $100? So I printed a nice little kind of thing like that wraps around it. So if I drop it, it helps protect it. Here's just a simple form for like an end-fed half wave, something to wind your antenna wire on. Looks like someone printed new paddles for their iambic. I don't know what that is, but I see a little connector there.
Looks like a centerpiece for a dipole antenna. The
Yeah,
insulator.
you've nailed it, you're right. Looks like a whole enclosure over there in the upper left corner. This is what I was talking about earlier, bushings and spacers for like a Yagi. Oh man, printers are great for antenna stuff. I just love it. Looks like someone printed a whole key right here.
Yeah, K6ARK.
What's that?
K6ARK has that. He does a lot of IOTA. Some that's on the air.
Mm-hmm.
He's got some downloadable free files that you can print your own.
Yeah, you mentioned printing stuff for antennas. I mean, which materials are like UV resistant and do well out?
Hey, that's a wonderful question. ABS is very tolerant to UV and weather. I have found that the PETGs, especially the darker ones, or especially the ones with a carbon fiber content, are pretty tolerant. They won't last forever, neither will the ABS, but they'll last a very long time. So I don't recommend that you make antenna components out of printed parts and put it up on your 60-foot tower, because you're gonna have to replace those parts probably within a couple of years, and you might not wanna climb that tower to do it. Side note on that, SLA, the liquid polymer printing, it uses UV light to cure the polymer. Guess what happens to that part when it's exposed to the sun? It gets cured more and more and more. The SLA parts are very intolerant of outdoor use, especially if they're exposed to UV, the sun. They'll begin to yellow and craze and crack. They're great parts, they're just not good for outside. And I actually did some studying on this about a month and a half ago to see if that had changed at all. Went to go look at some of the newer materials out there. There really are no SLA polymers out there that are good for UV. However, you can buy like Rust-Oleum, makes a clear coat for plastic that is a UV protectant. And you can spray your part with that, and it will really increase its lifespan. It also has the effect of making it look nicer, especially if you're printing in clear plastic. It'll make it actually clear. PLA, definitely not. Don't use PLA on an antenna part unless, like PLA would be fine, like if you're going to make a small little 2-meter, 70-centimeter Yagi for doing bird chasing, right, satellite chasing, and it's just going to be in your hand. It'd be fine. Just need to remain cognizant that the lower end materials like PLA, while they've improved their formulations tremendously over the years, it still isn't really high temperature tolerant or UV resistant. Oh man, what have I printed? Well, not getting into work stuff, I've printed just all manner of things. When I get bored, I like to go into my room and fire up the computer and go to Thingiverse and just browse. And I'm like, oh, that looks cool. And I'll download it and print it. My wife just loves it. I got a lot of fidget toys. But more practically speaking, especially on older radio equipment, we have those rocker switches that are plastic and they break. You can print a new one, and you don't necessarily have to design it. Touch on that for a minute, folks. There are some websites out there that have massive repositories of CAD. There's Bamboo Maker World, there's Thingiverse, that's a really big one. There's Printables, it's another really big one. There's Cults, and I'm sure there's a half a dozen or more other ones. But guys, I'm telling you, just about anything you can think of, someone's designed it. It may not be exactly what you want, but it might be. So I will often, if I want to replace a thingy, and I don't want to have to CAD it up, I don't want to have to take my calipers out and go measure the thing that I'm making the replacement part for, I'll search for it And probably 7 times out of 10, someone's already catted it up. They've posted it on Thingiverse or on printables. I'll download it, print it, done.
Is there any kind of open source commission site for?
Yeah, there are a lot, like printables.
Yeah.
They have a pay for section, and you can upload your stuff, and you can set the price for a download, that sort of thing. Cults does the same thing. I think Thingiverse does too.
I was thinking more along the lines
Oh,
of.
printing
say,
parts?
I have I have an idea, I need someone to do the CAD work for it.
Wow, that's a really good question, and I'm sorry, I can't answer it, but you've got me intrigued. Now, there are tons of 3D printing services out there that you can go to, upload your files to them, and they'll print it for you. But as far as off of one of these websites, I'm not sure. Like Thingiverse or Printables.
Yeah, because the issue I run into is with enclosures is trying to get something that's ergonomic and also resilient, and when something like that takes 20 hours to print, I'm just throwing a number out there.
Well, that's not off the mark sometimes.
Trying to put time and cost prohibitive to keep doing one-off experimental ones when, there's someone that does enclosures for a living. It's like, can I put a commission out there for say $20 for a enclosure the size of my hand?
You might be able to, but I can tell you this much, I wouldn't do it for $20. No way.
I'm just throwing numbers out there, because there's, for software, for example, there are sites you can go to where you can say, all right, I've got this open source program that tons of people use, there's this feature I want in it, I'll pay $120 towards that feature, and then other people can glom on and say, oh, I'll pay $50, I'll pay $100, etc., and then as the popularity
Well,
that
if
goes up.
again, you've kind of got me intrigued. I don't know. Sounds like someone needs to start developing a website if it isn't out there. Sounds kind of neat, kind of an open source makers forum sort of thing.
I'll throw this out there real quick, because for simpler geometries, I don't wanna put any engineers out of a job that use CAD all day long, but for simpler geometries, AI will actually generate
Oh yeah,
stuff.
and
So,
I use it for
Yeah.
home. I actually have a ChatGPT account, and I've had it design simple circuits for me and have it output in KiCad. I've had it do simple CAD for me. It does a decent job. I may be out of work here. Yeah, so this list, you guys have read it by now. The possibilities are genuinely nearly endless. You want to make a little bracket, hold something on your bicycle handle, you can, you name it.
Yeah, I have an old hot one. Everybody remember heat kit? I have a heat kit, hot water 5400, and the buttons that you use to push the numbers in, it's gotten worn down. Are there materials that I can use with the 3D printer to repair that?
So I'm not familiar with the geometry of the parts or the buttons that you're talking about.
Well, it's all one piece. It's a one rubber piece, and it pushes on a matrix.
Oh, I see what you're saying, kind of like a membrane.
Right.
Right, yeah, sure, TPU. Yeah, TPU. So you can buy TPU in all different hardnesses or durometers, right? You can get it, you can buy TPU to where it is just super duper spongy soft to
I'm in the
form relatively quite rigid and anywhere in between. And I have actually printed membranes for other applications for the same sort of application. TPU can be a little bit trickier to print because the filament is stretchy. And most FDM printers, they have an extruder at the hot end that's pulling that filament right through a Bowden tube. And what happens with TPU is that if there's any friction at all in that Bowden tube, for instance, the rolling resistance of the spool, it'll stretch the TPU and you'll end up with an under extrusion. And in other words, you'll end up with a big ball of spaghetti. So when it comes to TPU, you have to be careful, and primarily it's in friction reduction. Now, the bamboo printers do a really good job running soft TPUs, but what I do is that I will feed the filament right into the back of the printer, and I'll literally unroll the filament to where it's just a spool on the floor. I sweep it first, or put it in a box, so that when the printer is eating the filament up, there's zero friction, just as little friction as possible. That helps massively, really helps. Makes for really nice TPU parts. Even the super spongy stuff. We, at work, I use a lot of super soft TPUs as vibration isolators for like camera sensors, IMUs, things like that. Any questions before I hit the next one? So this slide pertains both to hobby side and for professional side, right? It's really awesome when you're trying to make something, design something, you get that instant gratification and fit check, right? I can print it in an early state of design. I can hold that part in my hand, often within an hour or two, and I can see if my concept has any chance of working, right? And get an idea of what I need to change, and rinse and repeat until you got a usable part. It's really nice. And again, no deburring. Let's see what we got next. Oh my, where's the technology going? Yeah, it's going everywhere. I really do feel that additive manufacturing is going to, and it already has, radically changed the manufacturing landscape. Now, additive manufacturing currently still has some pretty big limitations. The main one being volume, right? If I need to make tens and tens of thousands of a part, plastic injection molding is the only way to go, because I can run that injection molder all day, all night, virtually unattended, and it'll just keep pumping out good quality parts. With additive, I have to have a human in the loop, and it's relatively slow, and it's expensive. Those per part costs are fairly high. Beautiful thing about it, especially for military use, in the DoD, typically manufacturing numbers are very low compared to consumer product manufacturing numbers. And design iteration is very high, right? They need things changed all the time, almost on a weekly basis. And if I buy or have made a plastic injection mold, or I have some sort of traditional manufacturing process on a mill or a lathe or whatever, if I need to change that part, it can be extremely expensive to do so. With additive, not so much at all. I think myself, metal additive is going to become more and more common. And what I'm really looking forward to, and you touched on this a little bit earlier, there are companies out there now that are making PCB printers, multi-layer printed circuit card printers. They're really expensive, and they have some pretty good pretty tight limitations on how tight of a pitch they can go, how fine a trace they can print. But it's just a matter of time. I predict another 5-10 years, we're going to be able to print, high-speed data circuit card assemblies, and then it's going to advance into where we'll be able to actually print passive components, capacitors, resistors, things like that. It's inevitable. It's going to happen. And somewhat similar technologies, especially in the maker world. Our world is amateur radio hobbyists. Laser cutters. Laser cutters are really cool, and you can do all kinds of really cool stuff with them, especially making really nice panels. Now, like you were talking earlier about wanting to make a panel for a 19-inch rack, can't fit it on your print bed. most home printers aren't anywhere near big enough to take a full 19-inch width panel, but the laser cutters can. And if you have a sufficient power laser cutter, you can cut your panels out of plastic, out of wood, different materials, even some thin metals, depending again on the power of your laser. I actually think these numbers still hold pretty well. You can buy a really cheap low-end printer, one of the Creality Ender 3 type machines for $150, $200. And I'm actually a big proponent for people that have never printed and that like to tinker to buy one of those machines, because it will force you to learn how 3D printing works, because you gotta tinker with them. They rarely just work. We've gotten a lot better over the years, but they still usually require a little bit of tinkering. You gotta do some homework on YouTube. Why isn't this working this way with this material, that sort of thing. But you get into the higher end printers, especially the bamboos, they're plug and play. You just print with them. They're fantastic. Some of the more common printers out there, especially some of the Creality printers out there, there's tons of aftermarket support on these printers. You can buy all kinds of nifty upgrades, many of which are actually legitimate, helpful upgrades, like automatic software bed leveling systems, much higher precision hot ends that have much better control over temperature, have much higher quality nozzles, have much better extruder drivers for pushing the filament into the hot end. You can trick them out to just about no end. My first printer was an Ender 3. I paid $249 for it. By the time I upgraded and needed to give it another home, I gave it to a friend's son. I probably had about another $500 in it in upgrades. But that's what we like to do, right? Bling our stuff out. That's what we like to do. All right, a lot of this we already talked about. How to get started. There's a lot of online model repositories. There's a lot of good free CAD tools and free slicer tools out there. There's a list of printers that are still manufactured by reputable folks. And that's right, the free prints bullet there. I know that the Huntsville Public Library, at least the branch near me, and probably other good libraries out of town, I expect, but I know the one near me, they have 3D printers. And I can go to the library with a print file and print a thing. Yeah, it's pretty cool. Pretty neat stuff. All right. Now, any questions, guys? I hope you learned a little something. Yeah.
What are like the recommended computer specs for running like an AutoCAD program?
Yeah. That's another really good question. So, as a professional SolidWorks user, at work I have a hot rod, right? With a very expensive video card and tons of memory and all that stuff. But at work, I'm running really complex assemblies with very high parts counts and lots of complex geometry and material property definitions. I have to have a hot rod. At home, I've been running SolidWorks for better than 14, 15 years, and I have one of those little crappy microcomputer things. Works fine. But at home, I'm rarely designing anything, an assembly with a parts count higher than a dozen parts, right? I'm not developing or designing big parts with mountains of complex geometry in it, like a car frame, for instance. I'm not designing that stuff at home. So for the majority of us, you do not need a powerful computer. Just a run-of-the-mill desktop, laptop will do the job.
How do you put the last slide up again?
Absolutely.
Is
Any other
this deck
questions?
available on the
Uh,
internet? Get it from Gigaparts?
It is not, but I will get it to Robbie to post. Does anyone need to take a snapshot of that? I was gonna bring up this, see how much time we got left.
I got mine on.
I think we're out of time. All right, so, Robbie kinda left me up with, he's the owner of Gigaparts. He kinda left it up to me how to deal with this stuff. And quite honestly, that has me petrified, cause I don't wanna play favorites with anyone. Ooh, thank you.
Yeah, they had tickets at the last one, but.
Yeah, I didn't do that in here, wish they had. Yeah, I can pick a number.
Pick a number.
Pick a number?
Pick a number.
All right, I'll pick a number. All right, I picked a number. But if I do this, then I need to ask every single person for a number.
Yeah, that doesn't.
That doesn't work too good. Shoot, how do I do this?
All right.
A number and
I'll
everybody checks
volunteer,
their,
I'll take it.
Receipt.
Okay.
You don't have tickets.
So, how many